Hi, my name's Ibaad. I worked with Mayna, Elina, and Emma on our project for deep learning for sentiment analysis on music artists. We wanted to work on this project because music is a core part of daily lives for a lot of people, and we were interested in gaining more insights on top artists' lyrics rather than just the names of the artist. Currently, streaming platforms tell us who we listen to, but it doesn't exactly tell us how the music really feels. There's no easy way to see if your favorite artists are overall positive or negative in their lyrics. And being able to analyze those lyrics will give us a new understanding of not only the songs but also some emotional and thematic patterns that are not captured by genre or streaming counts alone. Computational music analysis applies NLP and ML techniques to understand artist expression, audience response, and popularity dynamics. Early approaches to music analysis rely primarily on aggregate popularity metrics and shallow text representation. We wanted to combine textual content, public perception, and temporal fame because it provides a more complete and interpretable representation of an artist's identity.
Into our related work, we see a lot of machine learning applied for social media analysis and audience consumer analysis already. We also see it being used for predicting music success. So here are some research papers. One research paper used to predict a song's commercial success, and there's also articles talking about the industry and artists being interested in using these ML analytics for understanding the patterns to artist success.
So, our primary goal is to build a comprehensive profile for the six most popular artists in the world right now, which are Drake, Kendrick Lamar, The Weeknd, Billie Eilish, Taylor Swift, and Bad Bunny. And so each artist profile will consist of their lyric sentiment and all of their songs, common themes and messages in their songs, the artist's public perception via social media, and the artist's fame over time. And so we believe that rather than just using a single metric like just lyric sentiment or popularity alone, won't be able to actually truly capture an artist's real identity. So instead, we aim to build well-rounded profiles that combine a vast majority of these different topics. So looking at why we believe this to be true, looking at just lyric sentiment alone in just the Billboard top songs over the last few decades, lyric sentiment has changed a lot. And so looking at just whether a song has positive or negative lyrics isn't a true indication of how popular a song is or how well an artist is doing. And also, music perception is shaped by music content, which we believe to be themes in their songs or lyric sentiment, music context, which could be artist fame over time, and user context, which could be public perception.
So our proposed solution breaks the problem into four complementary components. The first, for lyric sentiment, we use Genius Lyrics dataset and applied a Dilbert-based sentiment model to quantify the emotional tone of each music artist. Second, for common themes, we again use lyrics but embed sentences into SentenceBERT and cluster them using k-means to uncover recurring lyrical themes. And third, for public perception, we analyze sentiment across Twitter, Reddit, and news data using Roberta sentiment models and semantic embeddings to support retrieval-based analysis. Finally, for fame over time, we use historical Spotify popularity trends and forecast future popularity using SariMax. Together, these components will let us capture an artist's identity from multiple perspectives rather than just relying on a single metric. So next, we're going to go into the implementations of each section of this project.
So I worked on the lyric sentiment part of this project. So for the data ingestion and filtering, I use the Genius Song Lyrics dataset, which has around 5 million songs, just to ensure that we had a wide coverage of songs from the artists that we chose. And I built a filtration pipeline to isolate the discographies for our six target artists, and then I cleaned the metadata and standardization tags. For the model, I used Dilbert base uncased because it is 40% lighter and 60% faster, but it still retains 97% of Bird's performance. And I used a fine-tuned model of SST2 to ensure high accuracy binary classification between positive and negative. I also implemented truncation strategies to fit lengthy lyrical compositions, and I also aggregated song level sentiment predictions into normalized distributions. And here's a quick demo of the code.
we're using Distilbert, which is it's specifically a version fine-tuned on the SST-2 dataset. I chose this pipeline because Distilbert offers a great balance between speed and accuracy. And finally, we run the inference. For this demo, I'm sampling the first 50 songs for each artist to get quick results. And that took about 11 minutes to run. And these were the final results that we got. So the most negative here clearly is Bad Bunny. And then next place would be Kendrick Lamar. And third most negative was Drake. But yeah, these are the overall results that we got. It's basically looking for certain words or phrases to kind of classify it as more negative or positive, based on 50 songs from each artist. And yeah.
And just a graph and a bigger image to see the results. Same, like I said in the video, it seems that Bad Bunny is the most negative and The Weeknd is the most positive.
So I worked on looking at the common themes between artists. And so I go over this more in detail in the code demo, but first for data ingestion and filtering, I used the same data set as was used for the lyric sentiment. And because it was so big, I used a chunk filtering pipeline to just look at our 6 target artists and also only look at the artist name and lyrics columns because those are the only columns needed. And then I split the lyrics into sentences for finer thematic analysis, discarding extremely short lines. And I use SentenceBERT to embed the sentences so that sentences with similar meanings were closer together. And I used k-means and I chose k equals 12 to cluster the sentences to group semantically similar lyrics. And so in order to manually kind of identify which cluster would be linked to what theme, I used TF-IDF to look at the top keywords per cluster to understand the cluster meaning. And I mapped clusters to readable themes, so things like love, desire, emotions, introspection, things like that. And I had 2 different approaches for aggregation strategy. For data visualization, which again I go more into in the code demo, and I looked at the song level and sentence level, but I found that sentence level was much better for a more comprehensive analysis of the artist because it was less biased. So this is a quick demo of my code. This was the code for the thematic analysis portion of our project. So I used dataset from Kaggle. So here I uploaded the JSON file that had my API token. And so that's kind of how I downloaded the dataset. And here are my necessary imports and installations. And so after I had extracted the dataset, my first task was to filter. So I included only the artist and lyrics columns for our chosen 6 artists. And so here I include our selected artists, and then I used chunking to process the data. So I processed 100,000 rows of data per time at a time because the data set was extremely large. And then I filtered only the artist and lyrics columns, and then I processed all the chunks and combined them into one data frame. So here's the output of that. And then just to make sure that I was getting enough songs per artist, I just wanted to display the number of songs per artist that I got, which was each artist got over 100 songs, which I think is sufficient for thematic analysis. And then after that, I was able to split the lyrics into short text units using NLTK. And I removed extremely short sentences because they were likely meaningless. And then I embedded sentences with SentenceBERT using the all MPNet base v2 model. And I used batching here. And then after that, I was able to start k-means clustering. And I chose k equals 12 because I found that themes were pretty similar and I didn't think there needed to be more than 12 clusters. And in order to manually assign the clusters labels, I wanted to see the top 10 most important keywords per cluster. So I used TF-IDF for that. And then here you can see the output of the most popular words or most important words per cluster, and it grouped all Spanish words together. So that kind of skewed Bad Bunny's output because all of his songs are in Spanish. And then after that, I was able to manually map the clusters. So looking at keywords, I was able to understand a general theme per cluster. And then I went about computing the theme percentages per artist. So I had two approaches for this, and I'll go over the results more in detail in the slides. But this is my code for the song level. So this is basically assigning a song the most common theme in that song based on the number of sentences in that theme. But because the data was kind of skewed, I went about a different approach, which was basically computing just the general number of sentences in each cluster and using that to understand the percentage of the artist's work in different clusters. And that gave a more well-rounded output. Okay, so this was the first graph I produced, and this was at the song level. So this is kind of comparing between artists, but as you can see at the song level, there's typically one theme that kind of dominates for artists, and a lot of artists tend to have the same themes like of romance and confidence. And then for pie charts, this kind of is better for looking at specific artists and understanding the distribution. But again, it shows the same data because it's at the song level. And then this is at the sentence level. So there's a much more even distribution between categories. And so I believe that this is a better analysis of understanding themes in songs because one song can have multiple themes within it. And then again, looking at the top three themes, this was at the sentence level, but I decided to look at the top three themes for artists just to kind of check to see how accurate it was. And as you can see, Drake and Kendrick Lamar have the same top three themes, even though they're in a different order, which makes sense because they're both in the rap industry and they're top competitors, whereas Taylor Swift has more romantic and emotional themes.
So the third part of our project was analyzing public perception of social media through the different artists. So for the data sources that I decided to use, I used three different data sources. One was Reddit, which contained short Reddit posts about pop music and pop stars, labeled for sentiment analysis. I also used Twitter, which contained 1.6 million tweets extracted using the Twitter API. And then lastly, I used a news data source, which had around 200,000 news headlines from 2012 to 2022. So the overall goal of this part was to analyze artists' public perception via media datasets. So for pre-processing, I filtered three datasets for the target artists that we've been discussing and created an aggregate dataset with this. Next, I filled in sentiment and added predicted sentiment using the Twitter Roberta-based sentiment latest model. And then I also created graphs showing these different sentiments per artist per media source. And lastly, I created embeddings using the sentence transformers model and stored via face. And the pipeline for evidence retrieval and feeding the questions was used, and I used Gemini as my LLM. And then I also evaluated the different responses that this pipeline gave me using three metrics: answer relevancy, faithfulness, and contextual relevancy. So this code demo shows
So I'm going to walk through my notebook on artist public perception. The overall goal is to analyze public perception of 6 artists across 3 media sources: Reddit, Twitter, and the news, using sentiment analysis plus a RAG pipeline for question answering. So first, I set up the environment in Colab by installing the core packages: Face for vector search, Sentence Transformers for embeddings and re-ranking, Google Generative AI for Gemini, and Deep Eval for evaluation. I also set up the Kaggle API so I can download datasets directly into Colab, and I created 3 folders to keep the data organized, one for each dataset. So for pre-processing aggregation, I downloaded 3 datasets from Kaggle: a Reddit sentiment dataset, Sentiment 140 for Twitter, and a news category dataset. Then I standardized all of these into a single shared schema with things like source, ID, date, title, text, and sentiment fields. For Twitter, I had to map the data's numeric labels into negative, positive, neutral, and for Reddit, I normalized its label format to use the same 3 classes. The news dataset didn't come with sentiment, so I had to mark that as unknown initially. To filter for my target artists, I defined an artist alias dictionary, like Taylor Swift plus any potential aliases such as Swiftie, and I compile those into regex pattern that can be used for data parsing. Then for every row, I compute artist match, set has artist, and define primary artist as the first match. This outputs two data frames, all.df and artist.df, which has all the data, and then artist.df has the rows mentioning at least one of my artists in their text. Next, I run a sentiment model across all artist-related rows using Twitter Roberta base sentiment latest. This function scores sentiment transformer all sources, batches a text through the model, and produces three key outputs: the predicted label, a score capturing both sentiment and strength of sentiment, as well as a confidence value. It also stores all per class probabilities. So this method is important because it fills in the news article sentiment and also creates a single comparable sentiment signal across all Reddit, Twitter, and news. So after that, I generated various visualizations. So for this first one, I had it split up by source, so then each of the artists gets it per source, and the positive, negative, and neutral analysis of that source for that artist. And then for the second one, I just split it up a little differently. So I had it per artist, and then each artist had 3 different sources. Lastly, I produce a heat map that shows the percentage of positive sentiment by artist of source, which is a quick way to spot cross-platform differences. So this last section is the RAG pipeline. I built RAG text using the fields optimized for retrieval, and I embedded every RAG text using the sentence transformers model, normalize the embeddings, and sort them in a phase inner product index. So when a question is asked, retrieve evidence embeds the question, searches phase for candidates, then applies optional filters like artist, source, and sentiment. Then I re-rank the evidence using a cross-encoder, which allows the pipeline to be much better at choosing the best evidence. I package the top evidence into a citation format and then build a prompt that forces the LLM to only use that evidence, including citations, and quote the phrase in quotes directly from the evidence. For generation, I call Gemini 2.5 Flash using an API key, and the run RAG query method here returns the answer, the evidence data frame, and the exact prompt that was given to the LLM. Finally, I evaluate with deep eval using 3 metrics: answer relevancy, faithfulness, and contextual relevancy. I pass the retrieve evidence as the retrieval context, use Gemini as the model, and report whether each metric passes a threshold, along with reasoning. Here at the bottom, I ran a few test prompts. And for each of these, it outputs the answer using the LLM and RAG, and also the evaluation, so whether it passed each of the 3 metrics and its score.
And then these are just some of the graphs that I had produced. Again, this is a graph of per source per artist and the negative, neutral, and positive sentiments, as well as per artist per source, just shown a different way, and then also that heat map that I had shown. So just to give an example of the RAG query pipeline, for this question, which artist receives more polarized reactions, Taylor Swift or Billie Eilish, I give it the question and then do the run RAG query method to get an answer, to know the evidence that it was given, and then also the prompt that the LLM was given. And then I have it print the answer, as well as evaluate the RAG response. So this is an example of one of the outputs, and as you can see here, it cites various outputs, and it cites the things that it used in order to incorporate into its answer. And then here is just the RAG text, as well as the source and the model, the sentiment label model that it used in order to analyze it. And then this is the evaluation using deep eval and its scores of the specific response in terms of the 3 categories that we had, which were answer, relevance, faithfulness, and contextual relevance.
So the last part that we analyzed was fame over time, so we wanted to see how their historical fame may have projected their future fame. So for data selection for this part, I used the global Spotify Music global data set. And so here are our methods for the process. So the task goal for this was to model the artist's historical popularity. And for pre-processing, we filtered for our artists, converted their album release dates to years, and aggregated their yearly fame to compute rolling averages. For the main process, we estimated their trends of fame over time and identified spike years for them, and also applied a time series Max model to forecast for the next 5 years their popularity. So this is the code demo for that part. Fame over time section of our project. So starting with the problem setup, we're going to be using linear regression, mean absolute error, and max time series modeling. So here are our task configurations. So these are 6 target artists, and I've also defined the number of future years we're going to be forecasting into, as well as the evaluation horizon. So here we're loading in our data set. For this, we're going to be using the Spotify Global Music Dataset and specifically looking at the file that spans from 2009 to 2023. So for pre-processing, we're extracting the release year from the album dates to create a time index for each artist. We're also filtering out to only our 6 artists and dropping ineligible rows and aggregating their yearly fame and applying rolling smoothing. So here is this historical analysis of their fame trends. So we're plotting the fame over time, over years, and on the y-axis is their Spotify track popularity, which is a metric given by Spotify from 0 to 100. And they don't really clearly explain what it's about, but it tracks their listening rates and their general retention. Here is a baseline trend estimation. So we're using ordinary least squares to estimate a linear trend in fame for each artist. And we also skip the artists if they have too few observations. We fit the linear regression line, and then here is the table that we're making. So as you can see, some artists have very high trend slopes, and we'll talk about that later. And this is the visualization plot for that baseline. Next, we're defining a spike as a year where the artist met their top 10% of their historical popularity rating. And so we're filtering out those years for each artist and defining the quantile as the 90%. And we're also plotting that over the fame over timeline. And this is the summary table for the representative tracks for each year where they had a spike. And now onto time series forecasting. We're evaluating their short horizon forecast accuracy for each artist. And we're also fitting the star and max model and storing the mean absolute error. And here we have the alternative approach for artists with missing data. So we filter them and we create a pooled data set so they share the same observations but start from a different average level, as you can see we set here. And we fit that as well. And the combined forecast, we plot that here. And here is a bar graph that we plot with the predicted forecasted popularity by artist. And yeah, that's it for this section. Yeah, so talking about the results for this section, we can see that this is the historical analysis. So Taylor Swift steadily increased while Drake has a lot of variation in fame. We can also see that Kendrick Lamar and Bad Bunny have missing data. Here is our OLS baseline. So as we can see, Drake has very low R-squared value. So that means he has high popularity, but it's very volatile, while other artists like Taylor Swift and Billie Eilish have very sustained growth. And this is the spikes. And also the representative tracks for each spike. So these are pretty popular albums or tracks from each artist. And this is the result of the time series modeling. So we can see that for our pooled results, Kendrick Lamar and Bad Bunny, their time series modeling is a little bit simple. But for other artists with more data, we can see Taylor Swift has more variation in her popularity increase. And also The Weeknd has a lot of variation. And this is the forecast popularity. So we can see that Billie Eilish's average popularity still is more than all the other artists. And Taylor Swift also follows closely, and Drake has a lot of popularity as well.
So here we can see potential comprehensive profiles combining each of our sections together about an artist. So for example, this is Drake, and we get information about their lyrics, their themes, distribution, their public perception, and their fame over time, as well as their projected fame. And then this is Kendrick Lamar's. This is The Weeknd's. This is Billie Eilish's, Taylor Swift, and Bad Bunny.
To wrap up, we built multidimensional profiles for 6 popular artists by combining lyric sentiment, thematic analysis, public perception, and fame over time modeling. We used transformer-based models for sentiment and themes, analyzed public perception across Reddit, Twitter, and news with RAG pipeline, and forecasted Spotify popularity using SariMax. Some of the challenges included data sparsity, sentence versus song level trade-offs, and language mismatch for multilingual artists. Overall, this project highlights both the power and complexity of end-to-end NLP systems for music artist analysis.
So for future work, we wanted to extend the pipeline to a more diverse set of artists. We focused on six just for this project so that we could get interesting results for all of them. And we also thought it'd be interesting to apply to a larger scope, so genres instead of artists. As we saw with Bad Bunny, a lot of his analysis was simplified because of his language barrier. So we applied different models for that. That could be an interesting avenue, and also building artist to artist comparison profiles. So seeing how cultural events or controversy can affect a pop culture for the artist's perception or popularity. And here are references and just a general who did what.
Thank you.